Okay, today is our last new lesson before we have our quiz tomorrow. But what I'm going to do first is I'm going to go over last night's homework. Okay, and I have here the graphs that go with the equations you had for the front side of last night's homework. I know I didn't ask you to do all of them, but I am going to go over all of them so that I make sure you understand how to find intervals over which the function is positive or over which the function is negative. Now, when we're talking about positive and negative and we're speaking in terms of a function, we're looking at the y values. For positive, it is where the function is above the x-axis, because where it is above the x-axis, that is where the y values are positive. With negative, we are looking below the x-axis, because below the x-axis, the y values are negative. So if we look at this first one, f of x equals x squared plus 2x, we can tell precisely from the graph where the intersection is with the x-axis. So we can see that here it is above and here it is above. So those are our two positive intervals. So this function is positive. Okay, and when we write these intervals, we're writing them in terms of x values. So this one goes forever this way and forever that way. So if we go left to right, forever left is negative infinity. So this one goes from negative infinity to this x value. We can see precisely from the graph that x value is negative 2. And then again, this second interval picks up here at 0. And then that one goes all the way right. So it goes to positive infinity. Now this symbol, the u, in between these two intervals means union. So this function is positive over this interval and this one. Okay, now let's look at where this function is negative. So negative is where it lies below the x-axis. So this function is negative from this point to this point. So this one is negative over what interval? It's an x value of negative 2 to an x value of 0. All right, let's take a look at the next one. Okay, so in this one we have an x value here and we have an x value here that represent the zeros or x-intercepts of this function. I could tell this is 1/2 if I couldn't. I do see that this has a GCF, and if I factored out the x, it leaves me negative 2x plus 1. And if I solve this factor to find the 0, I could tell that when I move this over, I get 1 equals 2x. So x is 1/2. So it looks like 1/2, and now we verified that this x value is 1/2. This x value here is 0. So where is it positive? That's where, oops, I was using green for that one, so let me go back and change my color. It is positive just up above the x-axis. So this function is positive over the interval from 0 to 1/2. Now this function is negative below the x-axis. So it is negative both here and here. That's where the function lies below the x-axis. So my negative intervals go from an x value all the way over here, that represents negative infinity, all the way over here, positive infinity as we move left to right. So this one goes from negative infinity to 0. 0 is the x value right here. And then it starts again at 1/2, and it goes forever right, which is to positive infinity. Okay, I'm going to flip over to the next slide because I do believe this is your number 3. So this one has 3 zeros. And those zeros appear to be negative 1, 0, and 1. And I could tell from factoring that is exactly what they are. Now yesterday we didn't do factoring, we just did some estimation on the graph. But these are very nice and very simple, and it's very easy to see that 0, negative 1, and 1 are the 3 zeros of this function. So now that I know that, I'm going to look at where this function is positive. It is positive from here to here. And it's also positive from here to forever. That is where the function is positive. So when I go to write my positive interval, it is positive from -1 to 0, and then again from +1 to infinity. This function is negative where it lies below the x-axis. So this one is negative down here and between there and there. So this is negative from -infinity, because that's always as far left as we can go, to this x value, which is -1, and then again from 0 to 1. And once again, when I have more than one interval, I'll use the union symbol. Now this next one, I can see the zeros. They're here, here, and here. It appears it's -1, 0, and +3. And turns out I can also factor this one. If I wanted to factor out the negative x, I would be left with x squared minus 2x minus 3. And then this factors to x minus 3 times x plus 1. And do I see a 0, a +3, and a -1? So I was right by estimating, but then I verified it by factoring. So this is positive. This function is positive from here to here, and then from here to here. Went a little bit below here when I didn't mean to. Okay. And then it is negative from here to here, and from here to forever. So if I start off with that x value of -infinity, working my way towards positive infinity, where is the function positive? It is positive from -infinity to the -1, and then again from 0 to 3. It is negative from -1 to 0, union with 3 to positive infinity. Okay, I'm going to go back and we'll take a look at these. So when we look at these, I've got a 0 here, 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 and here. These zeros are at -2, -1, 1, and 2. So if I'm looking at where it's positive, this function is positive from here to here, here, and here. Where is it negative? It is negative from here to here, and here to here. So my positive intervals, I've got 1, 2, 3 of them. It is positive from -infinity to -2, from -1 to 1, and from 2 to infinity. It is negative, there's just 2 of those, 1, 2, from -2 to -1, and from 1 to 2. And then this one is just the reflected image of this one. So all it does is it takes and switches our positive and our negative. So now it is positive from here to here, and here to here. And then it is negative here, here, and here. All right, so we're just going to switch these two. So now my negative becomes my positive. And my positive becomes my negative. So I have 3 of those intervals. That does not look like a 2. Okay, there we go. All right, and now let's take a look at the last 2. These also have nice zeros. We have one here, 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 and here. So it appears this is -4, -3, 0, 1, and 2. And we want to know where it's positive. So positive is here to here, here to here, and from here to infinity. Negative is from -infinity to here, here, and here. So my positive intervals go from -4 to -3. It is above the x-axis. From 0 to 1, it is above the x-axis. And then again from 2 to forever right, 2 to positive infinity. My negative intervals go from -infinity to here. So from -infinity to -4. From -3 to 0, and then again from 1 to 2. This one here is just a reflection of this one. So I'm going to cheat a little bit. I'm going to steal it. And then I'm just going to change. So on this one, now we're just going to mark this out. We're going to make this one the negative one. And then we're going to make this one the positive one, because all we did was reflect this function. So the intervals that were positive are now negative, and the ones that were negative are now positive. Okay, if you have any questions about this, be sure to stop Miss Willoughby and ask her for help. All right, now we're moving on to your notes. You can go up to the shelf at the front of the classroom and pick up your notes if you did not do so on the way in. Today is another review. Oh, not your notes yet. Whoopsie. It's the back side of your homework. Go ahead and check that. Check these values here. This means the same thing as negative. This means the same thing as positive. Where is it less than 0? That's negative. Where is it greater than or? This one has equal to. So with the equal to, we'll include the brackets. With no equal to, we just have the parentheses. So make sure you take a look at that. If you have any questions about this page, let me know. So this is more review. And then this one we're not going to worry about right now. So we're going to skip this for now. And we'll talk about that later. Okay. So now we're going to today's lesson, which is average rate of change. Now, when we look at a constant rate of change, that's what we have with a line. And that same formula that you use to find slope of a line, y2 minus y1 over x2 minus x1, is also how we find the average rate of change between 2 points. So when we're looking at a polynomial function that is not a line, we would still use that slope formula to find the rate of change. How it describes how something changes over a unit. Well, with a graph, it's the change in the y's over the change in the x's. So if you are asked to find the rate of change, you just take your 2 points. You have a y1, an x1 y1, an x2 y2, and you plug it into your old slope formula. y2 minus y1 equals x2 minus x1. So if this is our second point and this is our first point, we would do 9 minus 1 over 3 minus 1. All right, and that gives us the average rate of change over that from those 2 points. Now, we could also say this is the average rate of change over an interval where x is 1 to x equals 3, or we could also describe that interval as 1 to 3. So these are 2 different ways we could describe the interval. So instead of actually giving you 2 points, I could say from an x value of 1 to an x value of 3. Or I could say for x values over this interval from 1 to 3. Now, let's take a look at this. Over the interval from 2 to 3. So if I look at my graph at 2, here's the point. At 2, the y value is 4. So to go from 2 to 3, this is what I'm dealing with, the 0.24 and the 0.39. So to find the average rate of change, which I abbreviate AROC, average rate of change, AROC, average rate of change, it is y2 minus y1 over x2 minus x1. So the average rate of change between these 2 points from an x value of 2 to an x value of 3 is 5 over 1, which is just 5. Okay, now let's look at B, over the interval from -2 to 0. I'm going to switch to blue for this one. So an x value of -2 intersects right here. An x value of -2 intersects the graph right here. So that is the point -2, 4. And 0, here is where we are at 0, 0, 0. So it's the difference in your y's. So it would be 4 minus 0 over the difference in your x is negative 2 minus 0. The average rate of change over this interval from negative 2 to 0 is 4 over negative 2, which is negative 2. Okay, now the last one is very interesting. What is your average rate of change from an x value of negative 1 to an x value of positive 1? Well, here's an x value of negative 1, and here's an x value of positive 1. So if we look at the slope between those two lines, the slope between those two lines is 0. And because the average rate of change is really our slope formula between 2 points, that's what we're looking for here. So this problem, if I ask you one like this, an average rate of change of 0, so those two values have the same y value, so the slope is 0. The average rate of change is 0. The y values didn't change. Okay. So, what if you had a different function? You didn't even have a graph, and it asked you to find the average rate of change for this function over this interval. Well, the first thing you got to remember is these are two x values. Your beginning x value, your ending x value. And we need to find the average rate of change between those 2 points using our slope formula. y2 minus y1 over x2 minus x1. It would be an average rate of change, not a constant, because the function I'm dealing with here is not a line, it's a quadratic. So we've got to plug these in. We can't just look at the slope, we got to plug them in. So first thing I'm going to do is take the function and evaluate it at a value of negative 4. What happens when I plug in negative 4? And you can use your calculator for this. Negative 4 squared plus 3 times negative 4 minus 4 is 12 minus 16 minus 12 minus 4. And 16 minus 16 is 0. So the first point I'm looking at is when x is negative 4, y is 0. That's my x1, y1. My second one, I'll have to plug in the negative 1. And negative 1 squared is positive 1. 3 times negative 1 is negative 3 minus 4. So I've got 1 minus 3 minus 4 is negative 6. So my second point is negative 1, negative 6. Now, I use my formula for average rate of change between these 2 points. The average rate of change is y2 minus y1 over x2 minus x1. That minus a negative makes that a positive. So negative 6 over positive 3 is negative 2. All right. Now we'll take a look at number 2. We can do the same thing. We're given this interval from x values of 0 to x values of 3 over this x interval. How does the function change? What is the average rate of change? And we have to say average because it's not a line. So we would evaluate the function f, given a value of 0. So it would be 0 cubed plus 0 squared minus 2 times 0 minus 2, which is negative 2, which gives us the point 0, negative 2. And then we would evaluate the function for a value of x value of 3. And when we do, we get 3 cubed plus 3 squared minus 2 times 3 minus 2. So this is 27 plus 9 minus 6 minus 2 is 28. So my second point is the point 3, 28. So now we have the 2 points in which we're going to find the average rate of change. So the average rate of change is y2 minus y1 over x2 minus x1. So it's 30 over 3. So the average rate of change is 10. We're going to have number 3 be a you try. Go ahead and hit pause, and when you're ready, press play to see the solution. Okay, the first thing we do is we plug in f of negative 1, and we get the opposite of negative 1 cubed plus 3 times negative 1 squared plus 2 times negative 1 minus 6, and this gives us a value of negative 4, which represents the point negative 1, negative 4. The second value, we're plugging in a value of 2, so we get the opposite of 2 cubed plus 3 times 2 squared plus 2 times 2 minus 6, and this gives us a 2. So our second point is the 0.22. So when we find the average rate of change for this problem, we would do average rate of change is equal to 2 minus negative 4, which makes a plus, over 2 minus negative 1, which makes a plus. 6 over 3 is 2. Now, as we're looking at all of these, you're probably thinking, average rate of change is really just slope. So what happens if I have a graph? Could I do rise over run? Because rise over run represents slope of a graph. And the answer is yes. Not only could you, you should. So if I were to ask you to find the average rate of change between these 2 points, another way we could do it is count my rise over my run. My rise is 2. My rise is 8. My run is 2. Rise over run is 4. So if I asked the same question and I said over this interval, you could just find this point of intersection, and count your rise over your run. Write that as slope, and you have your average rate of change over that interval. Okay, so now that you know how to find average rate of change, or you've reminded yourself about how to find average rate of change, I want to remind you that you have a quiz tomorrow. So go ahead and ask Miss Willoughby for the homework assignment. The homework assignment has some practice with average rate of change, but it's a good review for your quiz tomorrow. Good luck!